Okay. We're roughly going to have 2-3 lessons on trig. I'm basically just going to I want to teach you all the main parts of it so that those of you going to pre-calc next year, it won't be such a shock to you when there's 2 chapters, like 2 full chapters of trig and pre-calc. And like I've heard from a lot of my calc students, that they just kind of wish they knew more of it ahead of time because you end up using it a lot in the future. So I really wanted to teach it this year, just to give you kind of a basics. And if you're done with math after Algebra 2, whatever. You're all the better off for learning this because parts of this is used in real life. So we're going to start with right triangle trig. There's all sorts of different kind of trig. Trigonometry just means the study of angles, and which I know a lot of you probably feel like that brings back memories of geometry or something. In my mind, it's nothing like geometry. Geometry to me is mostly like, the study of shapes and like proofs and things like that. This is just stuff about angles. Okay, the main thing that all of this is going to be based off of is that there are 3 different ratios that get referenced. And angles are frequently used in triangles, probably the most. And so that's usually why a lot of it is based off of it. Now, I do have them on the whiteboard on the side, so it'll be up there while we're doing all these questions. I am not expecting you to have these memorized to start with, or I'll wait for you to get stuff written down before we talk about them. But this is pretty much what the next 2 weeks is based off of, all of this.
This is like something total, right? Oh.
Yes, I didn't bring it up yet, but yeah. Does that mean in geometry they just taught you SOHCAHTOA to try to remember them?
Yeah, they tell me.
Okay.
The line downstairs to get into school is outside the doors.
To get into school?
Yes, because they're making passes for everyone. I literally got here at 32 and the line was outside of school. It was crazy.
Well, then better not get here at 32.
Huh?
Better not get here at 32 then.
Yeah, I guess that's...
Yeah, I don't know. That's kind of weird. So they already put you in the computer then, I'm assuming, since they're doing the passes?
I realized that the line was so long that at 37 they just let everyone in.
Oh,
They only gave passes to a couple people.
okay. See, Hadley, that would have been a much better excuse than hail. Hail from a previous day, in fact.
There was a couple when we were getting here.
Really?
Yeah, but like these tiny little spots.
Oh, thought you were making that up.
No, I was serious.
Oh, weird. We hardly ever get hail. Not 2 in 2 days.
She thought her tires popped because of how loud it was, and I screamed.
Sarge almost got killed because he was mowing the lawn when it started hailing.
Oh my gosh, no. My friend had an interview and he was sitting in his car 10 minutes before he. Did you see the size of the hail?
I did. I watched from my window.
He sent it to our group. He's like,
Yeah, it was definitely nicer to watch from inside my living room than being outside.
mental breakdown. It was
Or being on the softball field. I bet that was fun.
That I screamed so loud, Maddie finished at my scream.
At least you guys have a dugout.
That's so scary because it like
Metal thing out, and there was like a bunch of lights.
Isn't there a roof on it though?
Yeah,
Yeah, okay.
there was a bunch of lights, and he was like, guys, get off the field and get into the dugout. I was like, we get in a metal dugout with
realized
lightning.
more than four slats, and there's only 4 tires.
That's a tough call. You either face the hail or face the lightning.
Maddie, I'm like, I think there's hail. She's like, oh. So we screamed all the way back to her house.
Yeah, it was weird.
Her yard was just filled with leaves from the trees getting annihilated.
I saw my neighbors like sprinting to their cars to pull them in the garage.
My mom put her car outside so that it can get dented so she can get the insurance money and get a new one.
I was tempted to pull my car outside so that I could total my car.
That's what my mom did.
My car was already outside, so my mom instantly texted me, was like, are you getting the hail down?
Okay, looks like, are most of you getting done-ish with this now? All right. So the part that's really hard to remember is that sine, cosine, and tangent are just talking about how the sides compare to each other, their ratios. So they just talk about how big one side is compared to the other. And like when you're using a calculator, when you're writing all this stuff down, like when you do sine of 25 degrees or something, it almost feels like sine is like a, you know, addition or subtraction or something, like an operation. But it's not. It just tells you how big the sides of a triangle are on certain angle sizes. And it definitely is hard to remember that at times. So that's why on the left there I wrote sine ratio, cosine ratio, tangent ratio. That's what they are. And it's hard to remember at times. I put descriptions for opposite, adjacent, and hypotenuse if you needed them. I mean, it sounds like a lot of you somewhat remember this from geometry. And that's perfect because geometry was just to introduce you to it. And I'm just going to kind of show you more of what geometry did. So the hypotenuse is always the longest side of the triangle. It doesn't matter what angle you're looking from, the hypotenuse is always the longest. And the opposite side is always going to be considered across from the angle you're looking from. So different sides can be opposite. It just depends where you're looking from. That's all of these. It depends where you're looking from. And adjacent is the one next to the angle you're looking from. That's not the hypotenuse. So I have SOHCAHTOA written at the top. And that's the abbreviation that a lot of people use to remember. Sine is, wait, I'm pointing with my fingers. But, so sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Traditionally, the worst part of SOHCAHTOA is remembering how to spell it, which is kind of key because it tells you what sides are what. And honestly, I don't really ever see SOHCAHTOA in books anymore. And that's fine. I mean, it's not like it's crucial, but for whatever reason, it just seems to be easy to remember. And so a lot of people use it. Okay, so here I just drew a random right triangle. So I made a 5, 12, 13. The 13 is the hypotenuse, no matter which side you look from. Yeah, we're pretty much going to take notes today, and then we'll do the homework on this on Monday, is my guess. Unless you guys would prefer the homework over the weekend, but I was assuming not, yeah. We just had our test, so I figured you could use a break. And then what I was really hoping this weekend would be used for is for those people who are behind on things to get caught up. Because this is basically the last weekend to do that. Last week of school, I don't usually take late stuff. I'm not having you wait until the last second to turn stuff in, especially at the end of the school year. So if you're going to be turning stuff in, it has to be next week. And I'll say that multiple times. I'll send some messages. But makeup work is not intended for the last week of school.
Can you still turn in
Oh yeah, I didn't put that in there yet, did I?
Okay.
If you remind me at the end of the hour or on Monday, and I will put that in.
End of the hour on Monday?
End of the hour today, or if we don't have time, Monday.
So this will be our last test of the year.
Definitely.
Okay, so our grade right now is probably like.
Pretty close. Well, I mean, like, if you do really badly on the last test, your grade could go down, but it wouldn't be able to go down a ton. I mean, and when I say badly, I mean like 50% badly, like. On the right-hand side there, that's traditionally how you see the questions being written. So what's in green there? Sine, cosine, tangent, they abbreviate them into 3 letters for whatever reason. So, you know, a lot of people have their calculators and they see the sin button. And so a lot of people refer to it as sin, cos, tan. I don't know. It's kind of weird that I get why they abbreviate it, so it fits on buttons. That's pretty much it. But the angle that's listed after it is telling you what angle you are supposed to look from. So if I'm looking at this triangle, that means this is my focus. And if I'm trying to find the sine of angle A, I would like to know the opposite side compared to the hypotenuse. So since sine is opposite over hypotenuse, the answer that I would put down for sine of A would be the opposite side length divided by the hypotenuse length. Does this somewhat bring back memories? I mean, like I don't know how much time you spent on this. I don't think it was a long time in geometry, but there's a lot of different trig stuff that's applicable in real life, even if you're not like directly using the angle things. Most every one of your houses, the roof is known as a 5/12 pitch. So, like if you go around the country, like down south, there frequently the houses don't have the same kind of roofs as up here. So, down south they don't get snow. And so they don't have to plan for snow because snow is super heavy. So you'll see a lot of houses down south that might even just have a flat roof, or the roof on the house is just very, very shallow. Like it's not very steep triangle. Where around here, we get snow and the snow stays on the roof, and so snow is really heavy. And so they try to plan the roofs to be strong, yet allow for the snow to slide off. And it's so there's different kind of roof pitches that you can order. Yeah.
Actually, fun fact, that's actually why Texas died,
Texas didn't die.
or not died, but Texas, out of Texas.
When they had that snowstorm last year?
Yeah, snowstorm.
Yep. Yeah, I mean, basically the houses aren't built for snow, so when they got snow, it's always weird to us when you hear that, like, states down south, they get an inch of snow and school's canceled for like 2 weeks. It's not even a joke. I mean, that happens a lot of times. And it's because a lot of them will get damaged. A lot of them will, for one, their cars aren't made for driving on the snow. So, but either way, that's definitely, I was going to say tangent, and that would have sounded like I planned that pun. We definitely went on a tangent. Okay, so here, let's try to fill these out together. We can call on people here. Wasn't there somebody in this class that was like asking to roll? Was it Diego?
Connor, that was me.
Oh, I just have a question.
Oh, go ahead.
You just leave it as 5/13.
Do you what?
Just leave it as 5/13.
Yeah, because the answer is telling you how the opposite side compares to the longest side.
Oh, okay.
There you go.
This is my first time seeing this.
It's quite fancy now that it's all decorated.
4 or 5. No one?
No, well, they're right next to you. Somebody outside was very upset.
3-7.
3-7 is also nobody.
Wow.
There's a lot of people gone today.
4. 4-0. No one.
I like how you looked over there at 0.
2-8.
2-8. Do you think you could help me? I mean, not sign of A, since we already answered this one. This is the same triangle from the previous page, so you guys didn't have to redraw it. I don't know if you were. Oh, it's the same triangle. Do you think you could help me fill out cosine of angle A? So, looking at the whiteboard, what two sides do we need for cosine? Perfect. Okay, so if I'm looking from angle A, so my focus is right here. Perfect. 12 is the side next to A, and 13 is the hypotenuse, no matter where you're looking from. So 12/13. Good, good, good.
4-2.
Did you plan that?
No. Nope.
I didn't even hear you roll.
I rolled when we were doing it.
Okay, Lucas.
It's going to be opposite over adjacent, so 5/12.
Perfect. Opposite side over adjacent side, 5/12. Okay.
3-1.
Bryce, do you think you could help me with sine of angle B?
Sine of B, that's opposite over hypotenuse, so that's 12/13.
Perfect. 12/13, the opposite side over the hypotenuse.
2-2.
Nobody.
3-1. 4-4. Wow.
Are you going to answer? I mean,
I got it.
you're allowed to be exempt.
So cosine adjacent and hypotenuse, so it's going to be 5/13.
Excellent. So the side next to it and the hypotenuse.
I got 2-9.
Opposite side over adjacent side, just 12/5.
Nice. 12/5. Okay, so it seems like you guys are pretty good at this already. Guessing you remember somewhat of it before. This is considered kind of the most basic of trig, is just like identifying it from a triangle. And then the more you get used to it, the more you start realizing certain things. I don't know if this is too tough a question to roll somebody. What's the biggest answer sine can be? Oh.
4-3.
4-3. Jake. I don't know if I should call on you for now. I was just kind of leaving it for anybody, but
What was the question again?
what's the biggest answer sine can be?
I would say like 1/2 or something.
Or something? Or something? Oh, that's fine. So I'm going to draw a really extreme triangle, but technically not even as extreme as the... So you're looking from that angle.
That angle.
Are the opposite side and the hypotenuse.
The opposite can't be bigger than the hypotenuse.
The opposite can't be bigger than the hypotenuse, but if I draw a triangle as big as possible, they could be But you're absolutely right with the first thing you said. If I draw a super extreme triangle where this is like 89.9999 degrees, the opposite side and the hypotenuse would be the same size as each other? Are you trying to answer?
Yeah, it would be equal.
They would be equal. The most extreme triangle you could draw, they would be equal to each other. And so the sine ratio, the biggest it can get is 1. And then that's going to be the same for cosine, because you guys probably noticed that these answers were all the same. Cosine, the biggest answer could be is 1. Tangent is going to be the only one of them that the answer can be as big as whatever. And that's because it's comparing the two legs of a triangle, which can be super different. But the legs of a triangle can never be bigger than the hypotenuse, and so that's why the answer can only be up to 1. You don't necessarily need to know that all yet. I just figured I'd kind of start throwing facts at you.
What is it?
Sure.
Alright, 2-8.
2-8. No, already had it.
No, that was we 2-9.
And 2-8.
Oh, we did?
Yeah.
I don't know
You already went, right? Yeah.
that. 2-2.
Also got that.
This
We're
is-
getting duplicates.
Oh, I got him.
Onyx is still keeping track of this. We're gonna
1-5.
what? No, don't laugh. Don't laugh because you didn't get called on. I suppose a lot of you don't even have these written down yet. I'll give you a minute. Yeah, I'll give you a minute.
Wait, are we only doing right triangles here?
Yes. I thought I wrote right triangle trigonometry on the. Oh, that's okay. But yes. So
It's lesson 1.
it can be different when they're not. So yeah, lesson number 1.
Does SOHCAHTOA still work for non-right triangles?
No. Well, I'll just say no. There is methods for doing it of non-right triangles, but they're weird. We don't need to have any reason to do that. I think you guys might have learned law of sines and law of cosines in geometry, possibly.
Yes, sir.
I was definitely not going to do that here with you. I think that's where a lot of students start feeling like things get weird.
That's where I hate geometry.
And it is useful, but
Oh,
I just want to teach you the main part of trig.
geometry in general sucks.
Wow.
You told me you like geometry before.
It wasn't my favorite, but that's far from sucking. Like there's a pretty big gap between not my favorite and sucking.
I don't know.
Algebra?
What's your least favorite?
Yes?
No, what's your favorite? What's your least favorite?
Least favorite what?
Just subject. Well, math subject. Well, math subject. Yeah, math subject. Yeah.
Geometry.
What's your favorite?
Calc. Why you look at me all weird like that? You guys asked.
Why calculus?
You haven't even taken it yet. Why would you question it? It's fun. Hey, I can be weird, all right?
No, you can't. You're a teacher.
Proofs just don't click with me. I don't know.
Clicks with me, geometry.
Honestly, there's parts of geometry I like quite a bit. I like all the shape parts and things, like areas and volumes. It's not that I don't understand proofs, they just don't come as natural to me. So I just don't find it as enjoyable. There is. Proofs are pretty important to be able to prove things. I mean, it is. It's important. I just don't like it as much. There's nothing wrong with not liking something. Okay. First thing you should notice. Is it time to wake up?
No, that's my night.
First thing you should notice. Those are the same size angles in these triangles. Obviously, I made them different sized on purpose. but it's the same size angles. Okay? Oh yeah, who did you roll? Oh, that's right. Did you,
For sine of 30 degrees, I did 2/4.
2 over 4? Perfect. And 2 over 4 I can reduce and write as 1/2. So usually you're going to be asked to reduce them if you can. It's not a huge deal, but... Brody, what are you doing on your phone? You were texting the answers to this? Oh. Question?
On a test, will we get dot points if we don't simplify it?
Yes. That's why I said that. I heard you already roll.
1-1.
Hank, can you help me figure out cosine of 30 degrees from this triangle? You don't have to know, I mean, like, just give me the correct numbers. You don't need to know the answer type thing.
2 over 4.
Nope.
I mean 3.464.
Yep. So cosine would be the side next to 30 divided by the hypotenuse. So 3 point. Did you just put your headphone back in? Oh, I thought I saw you put headphone back in. I was going to say, what the heck? Ah, that's not good.
That's good for you. That's one less distracted student.
It's not good for me if you use headphones or not.
Alright.
I already know the answers.
2, 2, 3.
It's good for you if you don't use them.
What the hell?
It's very difficult to focus when you're listening to something else.
Dude, I got
That's why I listen to music I don't know. So I can't like focus on that music.
I'll just stay silent.
featuring like 21 Savage on the track.
Okay. Sine of 60 degrees is also going to be 3.464 divided by 4. Now, if you guys can, type these in on the calculator. I don't know what this... So obviously 1/2 is 0.5. What is 3.464 divided by 4? It's going to be close to 1. It's going to be like 0.8. What is it? 0.866. Perfect. Okay, so now we've got decimal answers, and now we'll do the second try. Oh, yes. Question?
Do you have to put them in decimal form?
No, I did because they were already decimals there. And so usually writing a decimal fraction is kind of useless. So if you have a decimal within a fraction, you traditionally don't need to. I would have accepted this as a correct answer too. Okay, I heard you roll a while ago.
Yeah, I got 2, 3. 2, 3.
5 over 10.
Okay, so
1/2.
1/2 or 0.5. Good.
I got 4, 7.
Naima?
8.66 over 10.
Nice. Which conveniently comes out to be 0.866. I don't need a calculator for that one. A lot of duplicates?
Yeah. 3, 5. Have I called that one right?
No, but they're not here.
Oh, alright. This sits here.
You got to roll it in your hand ahead of time sometimes.
2-5.
2-5.
8.26 over 10.
Okay, next person.
3, 5. This isn't.
Yeah, that didn't help, I suppose, huh?
2, 4.
Hadley, what do you notice between the answers, between the top triangle and the bottom triangle?
They're the same.
Yes. Why did somebody whisper that to her? That was. I thought I heard somebody from up here. Okay, so here is what works out nicely with these. This is why they're also called ratios. What ends up happening is every single different triangle there is. So every single different right triangle there is. No matter how big the triangle, the sine ratio ends up being the same. So like I purposely drew two different 30-degree triangles. And they obviously have different numbers, but they have the same ratios. Now most of you, I think, still had your calculator in front of you. Okay, first thing phone. First thing we should do is your calculator needs to be in degree mode. So on the screen, yours is in degree mode.
It is?
Yeah. On your screen, it's either going to say DEG or RAD. You want it in DEG. If you need to change it, there's usually a mode button on your calculator somewhere, and then you should be able to choose degree. The graphing calculators automatically will be in radian mode, and they need to be changed to degree.
I don't even see degree on here.
If you hit the mode button,
I'm on mode, but there's so many things.
nope, one of them will say degree radian.
Oh, there it is.
Okay, if you have done that, I believe most of the phone calculators come with degrees to start with, but I could be wrong. If you type in sine 30, your answer should be 0.5.
Yeah, it is. Wow.
And that's kind of because of this same fact. No matter the triangle size, the ratios will be the same. So you can figure out these ratios for every angle size of every triangle. Which is kind of neat and kind of weird, like same time. But it's also very helpful. You guys have probably seen like driving by when people do the surveying. So usually there's some guy in a construction vest with a big tripod and a little camera looking thing, and he's pointed to somebody super far away. I see you guys are really attentive when you drive around, huh?
Yep.
Okay. So those are surveyors, and they do that to figure out like how high the road rises or how level your land is or whatever. And they do that using these facts. Is they measure the angle that they have to aim to, and then they know the distance apart so they can figure out the rise. So like if you want to figure out how steep a road is, things like that. Because like that's important for when you're driving, like say you're driving a truck. Some trucks are only allowed to go down certain steepness roads. And surveyors use this information to figure all that out, which we'll get to in a little bit. Okay, next topic is I've purposely picked a 30, 60, 90 triangle on the last problem. There's going to be two triangles that we use really often. This one isn't a question. So these are the two triangles you're going to use a lot in trig. And that's just because these two triangles cover all the common angles. One of them is referred to as a 30, 60, 90 triangle. One is referred to as a 45, 45, 90 triangle. The numbers that I wrote on the sides tell you how they compare to each other. So those are ratios. Like if you guys type in square root of 3 divided by 2 on your calculator, you'd get 0.866, which is the answer we got from that last page. And the 45-degree triangle probably makes the most sense to you because you understand that those two sides are the same as each other on a 45-degree angle. I know, again, I'm referencing another geometry fact that you probably disliked. I think I heard you roll before, didn't I? Who did you end up rolling? Oh, okay.
31, but that's
You want to answer again, Bryce?
2, 5.
Okay, Bryce is agreeing to go.
Alright, what's the question? Okay.
Okay, Bryce, referencing back to geometry. Let's say on that triangle, I knew that the two sides were the same as each other, so I called them 1. How would I figure out how long the hypotenuse was, just knowing the two other sides?
A squared plus b squared equals c squared.
Perfect. So the Pythagorean theorem gets used a lot in right triangle trig because you frequently may know 2 of the sides, but not the third. And so you're going to do a squared plus b squared equals c squared quite often. And you could have figured out the square root of 2 from that. That's what I was trying to say. Okay. Do you need me to leave this page up here yet? Okay. These 2 things will be used quite a bit when we are asked questions here. Like this page. And I still have the same 2 triangles up there. I told you, we're taking a lot of notes today. I see you have very little space left. Are you trying to like judge the person before you call on them or what?
Well, no, I'm trying to see if they're here.
Oh,
You?
are they here?
Yeah, 3, 7.
No, that's right there.
Okay. I thought it was somewhere over there.
No, this is 8, this is 9.
Alright. Got already got that. Dude, this is terrible. I got 4-2 again. Lucas, you gotta go.
Lucas?
All right,
Let me finish my.
Yeah.
we can have some repeats, I guess. Just because we don't want to roll forever.
Everyone I
Yeah.
rolled.
Lucas, going from this, obviously I'm not referencing like angle A or anything like that. So it says tangent of 60. So how would you find that answer? Where would you look from?
Where there's the 50 degree.
Okay, you'd go find the 60-degree angle, and so you know it's a 30, 60, 90 triangle. A 30, 60, 90 triangle has these numbers. So what would the answer be?
Root 3 over 1.
Perfect. The opposite side over the adjacent side, which is square root of 3.
Two, 3.
2, 3. Another repeat. Brianna, did you want to go again?
Sure.
All right.
There would be 1 over 32.
Okay. And it doesn't actually matter which one of these 2 angles you look from because it'll end up being the same answer. So, but correct. So adjacent side over hypotenuse, 1 over square root of 2. I am not going to worry about this type of answer. You won't. We'll go over that later.
1, 3. I don't know. So, no.
Jack. So sine is opposite side over hypotenuse.
Square root of 3 over 2.
Nice. Sounds to me like you guys have this down pretty good. Okay. Cosine 30 square root of 3 over 2. I actually kind of have a feeling a lot of you just wrote all the answers down already. So if you haven't, I'll finish them. 1 over square root of 2. Oh, that was close. 1 over 1.
And we got 1 for it for the last one.
Oh, we got more pages.
Oh.
1 4 though?
Yeah.
Okay, David, you're on retainer here. Okay, good. So what we're going to start doing now is we're going to start trying to find out information using these facts. So no matter the size of the triangle, these answers always work out the same. And we can use that to come up with other information. You don't have to draw these 2 on the left. I'm just putting there so you can look at them. There's like 3 more slides. What do you want me to say? You can turn the page.
No, because the back of it's for homework.
Let's go.
Are you left-handed?
No.
Then that's really unusual to write on the left
Well,
page
it's
and then
just
go on the back.
I did my homework. Oh.
Are you just writing on random pages in your notebook?
No, math section.
Oh, that's killing me. Okay. Well, just write small, I guess. Otherwise, I've got more paper up there. You can staple it in or something. Okay, so that purple triangle is what we're going to try to figure out. So we're only able to measure this. So like say this is your roof, something like that. You can measure the roof, but you can't measure this board. So if I want a 9-foot roof with a 30-degree angle, how long would I need to make the board on the bottom? 18.
Yep.
That is 100% backwards. You're thinking right. You were thinking right, but so the 9 has to be the longest side. I know you were trying to use the half to, yeah, which is good.
Okay, but let's.
It's also the wrong side, but you were still thinking good.
4.5 split.
Here's the way I usually approach this. Is I like to write the ratios next to the sides. So a 30, 60, 90 triangle, the 1 goes across from the 30 degree. The 2 goes across from, well, the hypotenuse. And the square root of 3 goes across from the 60. The only one that I ever remember is that the 1 goes across from the 30. And then this one's double. This one's square root of 3 is the side that I don't know. I always just remember the 1 and the 2. And then that one goes wherever I didn't draw. Okay. Oh, go ahead. What'd you ask? You definitely have a question. What?
I got distracted on the smell and now there's a lot of numbers.
I'll leave it alone at that. Okay. What I did was I wrote the ratio, the sizes of these sides. So every 30, 60, 90 triangle, like this one up here in the corner, has the numbers in the same spots. Now those are just ratios. They're not the actual size of the triangle. So like this purple one, I know that that side is like 9 feet or something. I could have written a label on it. I'm going to use these green numbers, the ratios, to figure out X. I don't know if you can figure it out just because of the way I wrote this yet or not. What you're going to do is set up a ratio. The number I know over the number I don't is equal to, what number am I going to put on the top? 2, because the ratio number is right next to the 9, and then I'm going to write the ratio number that's next to the X. Yeah.
Since it's a 30, 60, 90, isn't x just 2/3 of 9?
2 square root of thirds of 9? It's not a regular 3, it's a square root of 3.
Yes, but
So what you're saying is correct, but you would have to multiply it by, well, here, we'll just write it out. So solving these, you can do the cross multiply that you learned forever ago. So 2 times x equals 9 root 3. So cross multiply,
Yeah.
and then divide both sides by 2. So the reason I usually write it down as a ratio is because frequently it's super easy to get confused in your head whether you're supposed to multiply or divide by that number that you were talking about. Like on this one, you have to divide by it. You have to divide by the 2 over root 3.
Sure.
Well, that's why I'm showing this method.
That's what goes in for that length.
The length on the, yeah, and you can make it a decimal. I don't really care about that.
Okay.
But this would be the exact answer.
Did you count it wrong if you didn't make it a decimal? No.
I would consider it better if you didn't make it a decimal. So this is an exact answer. A decimal is just like approximate answer. I'm guessing the answer is roughly like 6, 7. I see some people typing.
7.8.
7.8? Oh, even bigger than I thought. Okay. Do you feel like you could try a couple on your own? So I drew one of each. One of each for you guys to see if you can figure out the missing side. And then we have one last thing that'll probably take us just a minute after this. I know the difficult part is going to be remembering this on Monday. I don't like splitting this between the weekend, but not really much choice. If I heard you whisper correct, you should use the triangles you drew in your right before this. You're a bad whisperer. So I usually put them in parentheses just so that I don't get them confused with the actual sizes. You don't have to. You guys can write it however you want. June 2nd. Yeah, you got quite a while. And we're not going to do a lot of lessons on this because it's new to you. So, okay. So I'm trying to figure out x. So I'm going to write x, and I'm going to write one of the sides I know. Sometimes you know both. And then I'm going to write the ratio numbers next to them. Because the x went with the ratio square root of 2, so I made sure that they're both on top. The 6 goes with the 1, so I put them both on bottom. It doesn't matter which one's on top, doesn't matter which one's on bottom. You could even write it as x over root 2 equals 6 over 1. It'll still work. It just, you have to line them up correct.
How would you do it if you're given both sides?
That's a good question. That's actually the next page. So this is how we do it if we're only given one side. So cross multiply, you get x times 1 equals 6 times root 2. And I bet some people on the next triangle possibly just knew the answer was 7 without doing any work. And if you did, that's fine. Because this side is always half of this side. So if you knew that, that's great. That's fine. You don't have to. When you set up the cross multiply, you'll still get the same answer. And what usually happens with this is once you figure it out, it goes pretty quick. I partially wish I would have been able to teach this right before you took the ACT because I know the ACT usually has a trig part on it, so I don't know how well you remembered it, but this would have been nice to know ahead of time probably. Anybody want this page up? Otherwise I will change it and show you your last problem and we'll be done. Well, what happened there? So if you know 2 of the sides of the triangle, I'll go back to Bryce because he answered this one earlier. If you know 2 of the sides of the triangle, how can you figure out the third?
A squared plus B squared.
Perfect, Pythagorean theorem. So I would say a squared plus 15. These are big numbers. What did I do? So 400 minus 225, I think.
Yes, 225.
So A is square root of 175, which is not a great answer. But that's okay. I'll just write that. Frequently, you're going to be asked questions about a triangle that you don't know the angle size, but you don't have to as long as you know the sizes of the lengths. Like this one says sine of theta. And it just says theta there. It doesn't tell us how big it is, but we don't need to know how big it is to do this if we have all the numbers. So sine of theta would be, this is exact same as before. There's nothing different. It's just knowing that this is called theta and you just go with it. It's like when I wrote angle A before. But theta is going to be pretty common to use for an angle.
It's just like if like the angle is x, right?
It's like if the angle was an X or an A or a B, yep. So they start using the Greek letters more often the higher up you go. And so theta is pretty common. Sometimes you'll see an alpha, like the little fish symbol. They frequently use those for angles. I don't know why, they just do. Okay, and that is it. You guys did pretty awesome. I'm impressed with how much you remember from before. I needed to take the long time today to get all the basics of everything down so that we could kind of move forward. Did I write one of them wrong? I just did them quick while I was talking, so I might have looked at the wrong side. I think we're okay. Thank you. Yes.
Is A squared the short side?
I made a squared the side I didn't know.
So A squared.
You can call it whatever you want.
Do A squared and B squared matter? I know
They're the
C squared-
legs.
Morning while I was getting ready.
A and B have to be
Like,
the
it
short
matter where you
side.
put it, where-
Nope, not at all.